Here we have three standard algorithms that can be used for multiplication and are visual to help students learn different forms of multiplication. Now at the start, right up here, we have line multiplication. Line multiplication is pretty cool because it actually breaks up everything through the distributive property and breaks it up by its place value. Now, as you can see here, I've made a key and it's color coded, so that helps demonstrate the different methods here. If we look right here with the red line, that represents the hundredths. The blue right here represents the tens place, and the green is the ones place. Now, as you can see, this right here, the vertical lines, they represent the sum of 122. Whereas the horizontal lines, as the blue here represents, as shown over here, the tens place, there are 3. So the 3 lines there represent 30, and then the 7 green represent 37. Now, anytime there's an intersection, that is a place of multiplication. Now, what this does is it breaks it down to a more digestible way for you to do multiplication. And whenever we have these little black boxes around these areas, that's where we can kind of group them together to make it even more helpful for us. So here we have 100 times 10 times 3, because each intersection is from the red line and the blue line is 100 times 10, and that happens 3 times in that box. So we can go ahead and put up that little algorithm up there at the top. Then we have 10 times 10 times 6, because 10 times 10 happens 6 times within that box. Then we have 10 times 1 times 6, because 10 intersects the 1 lines 6 times. Alright, now down here we have 100 times 1 times 7, because the 100 line intersects the 1's lines 7 times. And here we also have the 10 times 1 times 14, which is the 10's line intersects the 1's lines, the green lines here, 14 times. And then we have the 1 times 1 times 14, because as has been made evident by all the other ones, the 1's lines intersect the other 1's lines 14 times. Now we can add all of those together, and when we do all the algorithm out, we can add all of them together here, all of the sums and products, all the products to one sum, which becomes 4,514. And if you run that through your calculator, you'll see that that actually is the correct answer. Our next method is the area method here. Now, this is one of my personal favorites. The area method works very well. One way that we do is we break everything up via place value, and we set a grid for each value of for each place value that we have inside the numbers. So for 122, we have the 100s place right here, the 10s place right here, and the 1s. Now for 37, we have the 10s place and the 1's place. So the 10's place is occupied by 30, 1's is 7. And now any time that there's an intersection across and down, so think of it kind of like Battleship, whereas B4 is where you sink your battleship. Anytime there's an intersection by these two, or the 100 and the 7, or the 20 and the 7, or the 20 and the 30, and so on and so forth, that is a multiplication problem. Now we take all of the products that are filled out through here, so the 30 times 100 is 3,000, 7 times 100 is 700, 20 times 30 is 600, 20 times 7 is 140, 2 times 30 is 60, and 2 times 7 is 14. Now we take all those, put them together, and as you can see, I've already done the addition here from all the products, and our sum is 4,514. Just like it was up in the line multiplication, it works just like it does down here. And that's another great method. And lastly, but not least, we do have the lattice method. The lattice method is another great way to do multiplication. It is another form where the distributive property breaks everything up, and it really effectively helps you look at the math in a little bit different way. So here, what happens is everything's set up in a grid, and then everything is slightly separated across by the little hash mark lines that we have and on the diagonals. So what happens is anytime there's an intersection of the numbers, just like in the area model, what we do is we put the ones place on the left side and the tens place on the right side of the line. So right here we can see that 2 times 3 is 6, so there's actually nothing in the tens place, so we put a placeholder in there of 0. And then we have 7 times 2, which is 14, so we actually do have something in the ones place, so we have a 14 here and a 1 right there. Then as you continue on, we have another 6 with a 0 and a placeholder with 3 times 2, and another 14, and then we have a 3 times 0, a 3 times 1, which is another 0 on the placeholder with a 3, and a 7 times 1, which is a 7 and a 0 as a placeholder. So then what we do is we actually will add across the diagonals here. So right here, so it's 4 plus, there's nothing else there, so we can guarantee that 4 is going to be the answer there. Now we have 6 plus 1 plus 4 is 11. Now what we do is we go up and we actually carry the 1 into the addition of the next diagonal. So 1 plus 6 is 7, 7 plus 1 is 8, 8 plus 17 is 15. So we're going to put a 5 there, and we're going to add 1 right there. So 1 plus 0 is 1, 1 plus 3 is 4, 4 plus 0 is 4. Then we have nothing up here because it's a 0. So our answer, as you can see, is 4,514. There you go.